Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. In this episode, Rachel and I will be talking with Gbadebo Atewologun, Director of Structural and Architecture at Milhouse Engineering and Construction, about the impact of technology on structural engineering, navigating project changes, our experiences with the SE exam, and mentoring the next generation of engineers. I'm your co-host, Matt Picardle.
And I'm your co-host, Rachel Holland.
Now let's jump into the conversation of the week.
Hello, hello.
Hello.
Good afternoon.
There we go. Yeah, thanks for joining us.
No, not a problem. I'm glad that this was able to be set up in some fashion.
Yeah, and what was your career journey like, Gbadebo? How'd you get into structural engineering? How'd you end up where you are?
So for me, I was actually born in Champaign while my dad was doing his PhD in structures at U of I. So I had a little bit of a leg up in a way. So he finished his PhD in around 1991 or 1990. I actually remember being at the graduation. And so as time went along, as I was looking to see what it was I was going to do for work, he was a professor. He was teaching statics, dynamics, and thermodynamics also, and physics at a college here in the Chicagoland area. And so as I was thinking about things I wanted to do as I grew up, he mentioned engineering. I wasn't sure I was going to do structural engineering at first, so I started taking different types of classes. But I realized that I was better at when things were not moving, as I would say it. So buildings and bridges appealed to me, and I happened to be good at it. I was considering electrical engineering at some point, but it wasn't quite as intuitive, although there are a lot of similarities perhaps between certain electrical systems and the more esoteric areas of dynamic design for buildings. But at that stage, I found the structural engineering more relatable. It's something that you can drive around and see. And so after graduating high school at like 15, because I graduated more quickly, I started taking classes and I ended up pursuing structural engineering. I graduated from IIT and started working when I was about 20, basically. And
You're
so,
like Doogie Howser.
Thanks. Yeah. So I was definitely the youngest in all my classes, right? Although I didn't, I never would tell people that, But yeah, I started doing structures, and the interesting thing was my dad was able to help me because when I would have questions on classes, one of the first things he would say is, "Where's your free body diagram?" I always remember that. And so it was nice having somebody who was familiar with structural engineering and could help me at times when I got stuck on something. In the end, I ended up, starting my career in 2007, August of 2007, and worked at a few different companies over the years. Over the last basically 17 years, I've done industrial structures. I've worked in the nuclear field. I have worked now at Milhouse, for example. We're doing more buildings. When I was at Stanley Consultants, which is a company I worked at a few years ago, I worked on buildings as well, but also in the federal sphere, working overseas areas of high seismic, high wind. So I've had the opportunity to work on a lot of different projects. That's something that I like. And also, I think that structures are interesting. And so for those of us who are nerds like myself, it's nice to be able to take that math, that calculus, apply it to something that you can point to and tell somebody, look, this is the type of thing I can do. And at the same time, be able to provide for your family.
Yeah, that's what I tell the students when they're trying to pick careers. It's, for me, it was the same thing. I like geotech, and I almost went as geotech, but I like pointing at stuff that I could say I had a part in, the design, built structures, the built environment. And yeah, if you get any type of reward or fulfillment from that type of work, seeing your designs get built, I think for students, that's a huge thing that you should consider if you're considering structural engineering, because I don't think you can get that type of fulfillment from other professions.
Right.
Yeah, I agree.
What about, so 17 years you've been working in the field. What would you say, in your opinion, how have computers changed the field of structural engineering?
Well, I think when I first started out, I would still sometimes do calculations by hand, like calculation paper. And then what I noticed now over the years is that things have just become different as far as how we're generating calculations. Not only that, but the complexity that we can analyze. So I've used MathCAD, I've used different software like STAD, RISA, SAP, and things of that nature. But what happens is that these tools have essentially made it so that you can do things a lot more quickly. You can not only increase the rate of progress, but you can also analyze more complex structures. Now, the only problem with that is that younger engineers who come into the business, one of the things that we have to look at is how they are inputting the data and whether or not they can tell if things are wrong when they come out of the computer. And so when you're doing it by hand, I think that is something that is very helpful, that you can tell, okay, something doesn't look right here, but you can click a few buttons. I mean, I can teach a junior high student how to engineer something, but they won't have a baseline of knowledge to be able to tell that, oh, that column looks too big, or that deflected shape isn't what I expected. So that's actually one of the things that I mention a lot to people that work in my department who report to me, is being able to understand if your computer output is correct.
Yeah.
Whether or not you input the correct parameters, because, as that saying goes, garbage in, garbage out. It's probably the more important thing now is being able to work with computers, because they accelerate the speed at which we accomplish projects, but they can also exacerbate and accelerate how quickly errors are made.
Yeah, 100%. It's like that quick, I remember one of my first jobs out of college, you're calcing a beam or something and you get it wrong. And I remember my boss used to be like, you need to do a quick gut check. Does that seem right? And I'm like, oh, good point. Just look at it and did it come out kind of like you think it was going to, or is it different? Because if it's different, you probably did something wrong.
Yeah, that's true. And it's a skill that takes a little bit of time to get the feel for that, but it definitely helps, that type of self-check. I've done it many times over the years, and I look at a computer program or output, and I say, hey, something doesn't seem right. Like, for example, a place I was working at before, and working on something, we were generating seismic loads, and they said, okay, we need you to look at this. I look at the seismic loads, and my first comment said, something seems wrong. These loads are too high for Illinois, right? This is like California type loads. And sure enough, one of the parameters was off by a factor of 10. And so that's why.
Yeah.
So that's why.
Yeah, like a younger engineer wouldn't know that. They
Right.
just don't have enough experience to have that sense of it all yet.
Yeah. And sure enough, we changed that parameter, and then the loads became what I thought they should be. And then we were able to, progress on the project.
Yeah. And it's pretty much what you're doing with the newer engineers. It's asking them those questions. For me, that's what I try to do all the time when I'm back checking work for young engineers. It's asking them those questions so they can learn how to ask themselves those questions. And then when I ask them again, they've already got the answers to it, so they can get better answers, more accurate answers, and the gut check. Because I think, yeah, with all the computers, it's so important to do the gut check now.
Yep, certainly.
And Gbadebo, what was I know you worked on a lot of projects, so those were pretty varied. How do you manage maybe the designs and the scopes of those? Were there any particular projects that stood out that had crazy scope or design changes, and how you handled those?
Yeah, so I think a lot of what happens with structural engineering in general is there's a little bit of tension that exists between structural engineers and the architects. And so one of the things I found is very helpful over my career is just making sure that working with architects, that you take away that tension or that friction that can exist, and ensure that people understand that there is some empathy that happens with engineering. And what I mean by that is helping somebody who maybe isn't in our discipline understand how design changes affect things further down the line. So I worked in a project, for example, when I was at Stanley Consultants with one of our in-house architects, and we were trying to figure out a way to have a large conference room in a structure in a high seismic area. And so initially the idea is, okay, we don't want to have any columns. And so what I explained to the architect who I had built some rapport with was that we can do that, but it means A, B, and C. And so when I would present things in that fashion, it allows people to think a little bit outside the box and realize as structural engineers, we're not just trying to tell you no all the time. We're trying to help you see how the load path and how design decisions will affect things further down the road. We're working on our project right now with an architect, for example, and it has a very beautiful cantilevered canopy area with 3 stories above it, and it looks great. You look at the renders and it's fantastic. And one of the things I did right away when we met with the architect, we see this render, and as I assigned my lead engineer, is that it's not that it's impossible. We can do it, but we need space for a large girder to be able to handle that load. And what that means is your columns are going to be larger in this adjacent area. Your foundations are going to be sized a little bit differently. So as long as you're ready for us to make those design decisions, then that means that we can achieve your dream. So the thing I find that's helpful as a structural engineer is sometimes we just tend to be numbers people. We just say, hey, we slide the calculation over. We say, look, it doesn't work. But thinking about that other side of it, the psychology, the empathy, and saying, being able to explain to somebody why it's not working, or perhaps why it's not working in the way they intend, gives people the information that they need so that they can relate more to us and understand not only the engineering cost associated with it, but also the time that it takes and the technical proficiency you need to achieve a certain aesthetic vision or configuration that maybe is outside the box.
Yeah, I think that's great. I mean, it's all about, the end result is getting a project that everybody's like happy with, and being able to collaborate successfully like that is like so important. And it's about the communication, having that empathy, being able to explain it, giving them the option to like decide whether or not it's worth it or not worth it, or how they want to proceed,
Exactly.
Yeah. What about in terms of, you talked about some of the younger engineers that you've worked with and stuff like that. How do you approach mentoring younger engineers while they're growing in their career?
So I think this is a crucial part, of our profession in general, of the business, is ensuring that we train people correctly. The reason why that is not only due to having certain, not barriers, but stage gates such as licensure, but also ensuring that the knowledge is passed on correctly. Because all of us at some point were young engineers that had to learn what a flare bevel groove weld is, because maybe they didn't teach it in school, right? And so when I work with younger engineers, what I try and do is to break them out of the habit of treating it like school. And what I mean by that is at school or in college, at a university, you're graded on your ability to perform on your own, right? If you're taking a test and you ask the person next to you, hey, help me out with this, obviously you're going to get penalized. But once you graduate, you have to flip that paradigm and realize that most of this work, most of the things that we're doing has already been figured out by somebody else. And so you have to ask questions when you get stuck. Because now, as a manager, as a supervisor, I tell them, I give you bonus points when you ask questions, not when you sit down and just make it a science project. So I really endeavor to create an atmosphere where they feel comfortable to ask questions, realizing that it's okay. You can ask the boss or your boss's boss questions. And even if I'm busy, still, I will make time to answer those questions. So that's probably one of the larger challenges, is making sure people understand that not knowing something is something that happens to everybody. There are still things I don't know. I know that when I retire, there will still be things I don't know. And as I work with engineers, many people have technical ability. Many people can learn and read the code, but it's ensuring that they're ready to work with the senior engineers, with their supervisor, and ask the question. If they don't understand something, ask the question. It's always better to ask the question.
Yeah, it's do your due diligence, try to come up with an answer, but there is a time limit, right? If you get stuck, ask me, because you'll learn, but then you're a professional, you're getting paid, and there's budget and all that stuff. So coming up with the questions as a manager, I get scared when they don't ask questions, because I'm like, I know you're not a pro at this. So
yeah.
What are the questions?
Yeah.
And yeah, I think making it clear to them, it's that, yeah, I know I look busy and I'm on the phone all the time, but it's our job to help you figure it out. And if you're not asking questions, it's only going to stunt your growth. And yeah, I think that's always encouraging them. That's sometimes a challenge, but getting it through their heads, ask the questions, because we don't know.
And we wouldn't be where we are today if we hadn't had people answering the questions for us, So it's like,
exactly,
people are pulling you up and you have to turn around and help other people get there as well.
Yeah.
Yeah.
And like the other thing too is that I always tell them, know your scope, schedule, and your budget. I said, when you're in school, you have a syllabus, you know what you're going to get graded on. So I'm going to grade you on scope, schedule, and budget. Know the answers to those questions and realize that after you have maybe struggled a little bit, there is a clock, right? So we need to make money. Therefore, ask me the question.
Yeah, and then it's like I'm on the phone, right? And they're asking me, why are you on the phone all the time? I was like, well, it's because I'm asking questions. I'm asking questions to my principals on the stuff that I don't know.
Exactly.
You should be doing the same thing.
Yeah, no, I mean, exactly. I tell them, I say, look, don't feel bad to ask me a question. I said, because I'm literally paid to help you.
Yeah.
So it's part of my job. It's part of my responsibilities to help, younger engineers.
And Gbadebo, what's your approach to, let's say you got a new project, new architect that you never worked with before. What's your approach to ensuring that the collaboration between you and the architect goes smoothly? Yeah. What's your strategy on that? Take them for lunch, or how do you set up the expectations for that?
Well, lunch always helps. But the thing I really try to do is take the time to get to know the architect, get to know what they are trying to achieve. And then also keep the communication frequent and proactive. So I will sometimes set up meetings and say, okay, we're working on this building. We're going to have a meeting about column locations, because as a structural engineer, we know we need the column so the building doesn't fall down. But as an architect, you don't necessarily want a column sticking out of a wall. You don't want a column in the middle of a space that you need for meetings and things of that nature. So I like to get involved early and often, make sure that they realize that we're on the same team. Like the collaboration that you mentioned, Rachel, is very important. So setting the tone from the beginning and saying, okay, this is how I like to run the project. I want to become somebody that you're talking to almost more often than your significant other during the day on this project, right? Because not only do I want to build rapport, but I want you to have buy-in on certain stage gates in the project. So if I run into a problem and I say, hey, I need a brace here, I'm not going to just put the brace there and then you find out when we have a review meeting weeks later. I want to call you right away and say, hey, we need a brace here. What can we do? Because then the architect is realizing, oh, they're trying to get ahead of any type of complication or problem. So those are the things I do. I like to send out even a weekly or biweekly status update, something I've used very frequently on projects that I manage. It not only provides a written record of things that we've discussed, emails, things of that nature that have happened during the week, but it just allows for there to be one place where I can put down my thoughts, notes, progress made, progress that we're going to make in the future, and also perhaps crucial information that we need from the architect or other clients.
Yeah, that's great. What about getting people interested in pursuing engineering? So you said your dad obviously had a really big influence on you going into structural engineering. What initiatives have you seen or different things out there that are working to get younger people interested in pursuing this career?
Well, something that we've done actually here at Milhouse is there is a separate kind of wing of the company, a nonprofit, that works with ensuring that children in all types of communities can see that engineering is a possible career path. So I think that that's something that's really crucial. Sometimes people are not even aware of what it takes to be an engineer. So I have done a presentation, for example, with the wife of the owner of the company and with some other engineers explaining to adolescents and teenagers how to become an engineer. What are the benefits of being an engineer, not only from a work standpoint, but financially? That's probably the thing that people like to know about. At other places I've worked as well, we've gone to different elementary or junior high schools during Engineers Week and essentially explain to different kids, like, okay, this is what engineering is. This is how you become an engineer. Some people aren't aware, for example, that you can become a structural engineer, usually with only 4 years of school, right? So getting children to understand the possible career paths early is a key point. And sometimes people are just not aware of those things. So when I've gone to different schools, I will use an example that's very obvious, maybe like the John Hancock building or another well-known building in Chicago, and say, hey, you guys have seen this building, right? This is how we designed this building. And then it makes people think, oh, this is halfway fun and it pays well too. And from there, they can get interested in structural engineering.
Yeah, I love that. I feel like without a parent that's somehow involved in the industry or something like that, I do feel like structural engineering is something that is easily overlooked by young people. And I know we do a lot of that at Simpson. Like we'll have like the whole sixth grade and like a school come in and show them a whole bunch of things. And I love being a part of that because I just think like my dad was in construction, so I had like that point of view. But I just think it would be so cool. Like I feel like even when I went away to college for it, I was kind of like, I don't really know what this is, but I'm gonna go do it. So it's pretty awesome to be able to show younger people more, give them more of an insight.
Oh yeah, definitely. Because it makes all the difference. I mean, maybe if my dad were a structural engineer, maybe I wouldn't have decided to go down that path, right? And so in the case of when I interact with people or I go to a school or there's some type of presentation, it kind of gets their interest picked essentially. Like, oh, okay, this is something we can do. It's going to require math, but I don't have to be a math genius, but I can be somebody who understands how systems go together. I can have a reasonable work-life balance and at the same time be a structural engineer.
Yeah.
Yeah, that's it. I think your story even goes to that where the industry wants to recruit the best and the brightest. But if the best and the brightest don't even know what this profession is or what we do, they're going to go someplace else that's maybe more mainstream, maybe become a doctor, lawyer, these other professions that are more well-known because they see it on television. But if you didn't know about it from somebody, because I know the kids don't know what it is. So it takes someone that knows the profession, that's been in it, to tell them in a way, communicate to them in a way that, yeah, this is a good profession. And if this is something that you like, it's,
yeah, that's what we need. We need a TV show with the main character being a structural engineer that all the kids are watching.
Yeah,
CSI Forensics, right? CSI Forensics, where their building collapses, and then how did this happen?
Yeah, something to make us look like superheroes. I don't know.
Yeah, and I know, Gbadebo, it seems like you're a great communicator, and obviously with the positions that you've had, great leadership skills as well. Where did you learn that, or what's your approach to that in terms of communication and leadership?
Well, as far as communication, I think that's definitely an area where at times engineers could be lacking, or it's an area where we can improve upon, right? There's the old joke that how do you tell who's the extroverted engineer? Well, he or she is looking at the other person's shoes.
Yeah.
So how do you hone that skill? I think for me, it starts off with practice, right? You have to find a way to relate with somebody, find a way to talk to them in a professional fashion, right? Because being able to communicate a vision and explain something will oftentimes differentiate people who are just shooting out calculations or churning out calculations to people who can actually lead an organization. So how do I continue to work on that? I think it has to do with understanding where people come from. So I like to find out about people. I like to find common ground and also give them the respect that's due, right? So I may be a structural engineer and I may know a lot about structures, but I don't want to assume that because somebody is not a structural engineer, they're not intelligent or that they're not going to be able to understand what I'm saying. So ensuring that you treat people with respect, that you're not arrogant or acerbic when you talk with somebody, those are key points. And then the other thing that's always helpful is smiling a bit, right? So when I'm trying to give somebody bad news, maybe it's a client, they want to do something that's not going to work, get them on the phone or get them via Teams or some fashion, build that rapport in person and give them the bad news in person and smile. Those are things, that soft skills, which can really help differentiate people. And then even from a leadership standpoint, again, it has to do a lot with putting yourself in the other person's shoes, like looking to see, okay, how can I motivate this person in a way that will be effective? Everyone reacts differently to stress, to stimuli, to things that are not going well. And so you have to understand the people that are working for you, that are working in your department, so that you can ensure that you're attenuating your communication style, your management style to that person. Because if you don't do that, then you won't be successful either as a leader or a communicator.
So is there like something that you did specifically to learn those skills? Or is that like just sort of like how you were raised? Or like, do you read books or leadership courses? Did you learn it in college? Like what would be like somebody that maybe is trying to improve in those areas? Like what would be a way for them to like navigate that?
Well, I know that there are different courses that have to do with public speaking, for example. that's something that maybe isn't everyone's forte, but it's also one of those things that as you practice it, you get better at it. In general, I think for myself, I do like to read books. I am, like I said, a nerd, but I also like psychology and I like to understand people. So part of it is just my personality. I like to get to know what motivates a person so that I can understand and relate to them better. So that would be something that I think is helpful, right? If you're an engineer and you're great at bending moment diagrams and, figuring out block shear on connections, like learn to relate to people with that same sort of zeal, basically. Read a psychology book. Understand that a Myers-Briggs test, for example, can tell you how to interact with people who you say, wow, I don't understand that person. But ask questions. That's the other thing. Sometimes you may not understand something and you can ask a question and the person will be able to explain themselves. You can say, okay, rather than make the assumption. As engineers, we understand that making the wrong assumption can literally lead to loss of life, loss of property. So with a person as well, don't just make assumptions as to what is the motivation behind somebody's actions. Use the emotional intelligence that we have to various degrees and also ask people for feedback. So for myself as a supervisor working at Milhouse, I'm not reticent to ask the people I manage, how do you think I'm doing? What would you like for me to improve? Things like that not only give people the feeling that they're important, which they are, but it allows you to see really, is your approach working? Is your approach not working? And those are things that are key, I think, as one tries to navigate through the business, through the challenges that exist for structural engineering, not only technically, but interpersonally as well.
Right. Those are a lot of good tips. What about a final piece of advice for younger engineers today, aspiring engineers? What is something that you wish someone, like a piece of advice that you wish somebody would have given you early in your career that you'd like to pass on?
I wish they had explained to me how difficult the ACI code is.
Appendix D back in the day.
Appendix D, chapter 18, right? No, I mean, I think the thing that I wish that I knew at the beginning was, believe it or not, the importance of understanding relationships with people and understanding that how you relate with people will have a large effect into your career trajectory, how easily you're able to get things done, whether or not people help you, the flexibility that your supervisors afford you, how likely a client is to accept a change order, right? How likely a client is to afford you extra days on a deliverable. Those are the things which I wasn't necessarily aware of when I first started. And then also too, something else crucial is just understanding the importance of the scope, schedule, budget, those three things. Because initially when I started out as an engineer, I didn't realize the importance of getting things done on time in the aggregate sense, meaning schedule, but also the budget, the amount of hours that I was expending. And it's something that I sort of had to just learn on the fly, realizing, oh, this is how I'm being graded. So whenever I hire somebody, that's one of the things I tell them. I said, look, nobody told me this when I started until maybe, I don't know, my first or second year review, right? And trying to help them understand that when it comes to the hallmark of a good engineer, in addition to obviously being able to relate with clients and coworkers, but are you able to get done what it is that you were asked to do? Can you finish it within the time allotted? And can you do so efficiently while keeping in mind quality? So we obviously don't want anything to happen with the structures that we design. I think people are cognizant of quality, but some people believe they can take a year on something and you don't have a year. You need to work proficiently, but at the same time, hit those metrics which are important for our business, for our field.
Right. That's great advice.
Yeah, thanks for summarizing that in just in a very simple way for a new engineer to know. And I just want to thank you, Gbadebo, for coming on and sharing your stories and your advice. I think this is really great just because I think you're one of the examples of, for me, a good structural engineer should have all of those things. Technically, yes, obviously, but the communication skills and the leadership skills and the passion to help others and help students get into the engineering industry as well. So I thank you for sharing all that with us. And just thanks again.
No, not a problem. Thanks, Matt. Rachel, appreciate you guys taking the time as well to talk.
I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There, you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during the episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.